Okay, this is the homework help for Honors Math 3 supplement packet for Unit 3, and this is for Worksheet 8. So I'm going to start with question number 1. So the first thing I want to do is I want to find my possible roots. So I look at my factors first of my constant. So I know it can be positive or negative because if like 2 works for here, so would negative 2, right? So I'm looking for numbers that divide evenly into 24. And so I usually start with 1 and then work my way up. So 1 divides into 24, and then so does 2. And again, if positive 2 divides into 24, so would negative 2. 3 divides into 24, so does 4. 5 does not divide evenly into 24, but 6 does. 7 does not, but 8. And then so on and so forth. So I know 12 does, and then finally 24. So these are all the possible factors of 24, all the numbers that divide into 24. And then I look at my leading coefficient, which is 1, and I would divide all of these by 1. And so that won't change its value, and so I know these are all my possible roots. So then what I do is I'm going to use synthetic division, so I'm going to set this up. So I have x to the 4th, the coefficient is 1. There is no x cubed, so I'm going to use 0 as a placeholder. And then x squared has a coefficient of negative 15. And then x to the 1st, negative 10. And then my constant, which is 24. So I do, because this is a degree 4, I should have 5 terms, right? The 4x terms plus my constant. And so I always want to count to make sure I didn't leave out a 0. And so I'm going to start with 1 and see if 1 will divide evenly. And if it does, I would get a remainder of 0. So I carry down the first term, and then I multiply everything that shows up down here by this number here, which is 1. So 1 times 1, and then it moves up. And then I add, so 0 plus 1, and then multiply by 1. And then negative 15 plus 1, and then multiply by 1. And then combine those. Multiply by 1, and then combine. So I have a remainder of 0. And so I would try 1 again to see if there's a double root. So I'm going to try 1 again. So 1 times 1, and then add 1 times 2, and then add, and then 1 times negative 12. So that gives me negative 36. So I did not get a remainder of 0, so that means 1 is not a double root, so I'm going to go ahead and erase that. And then I would try negative 1 to see if negative 1 works. So I have pre-done the problem, so I know negative 1 won't work either. So if I tried negative 1, I would get a remainder that's not 0. And then I also know 2 does not work because I tried that. And so if I tried 2, I would not get a 0 remainder. But I know negative 2 does. So I'm going to just go straight to the ones that do work. So that would be negative 2. And then I'm going to do synthetic division again. So I bring down 1, and then I'm going to multiply everything by negative 2. So negative 2 times 1, and then add these together, and then negative 2 times negative 1, and then add those together, and then negative 2 times negative 12, and then add those together. So then I got a remainder of 0. And then as soon as I get a trinomial, so meaning 3 terms, then that means I can factor like normal, and I don't need to sorry, I don't need to keep trying guess and check. So remember, my goal is to factor, so I'm trying to factor that. So I know the 1 was a 0, so that means its factor is x minus 1, right? We want to do opposite there. Negative 2 is a 0, so its factor would be x plus 2. And then this trinomial. So this is my constant, x to the 1st, x squared. So that would be 1x squared minus 1x minus 12. And then now I have a trinomial, and I can just do normal factoring. And so that would be -4 and +3. So now you need to find your x-intercepts, your y-intercepts, your multiplicity, degree, and all of that, and then graph it. But I'm just going to do the factoring part for you. Okay, so there it is factored. And then let's do one more. Let's look at number 5. So I'm going to list my possible roots. So numbers that divide into -12 or 12, so that would be 1, 2, 3, 4, 5 does not, 6, 7, 8, so on and so forth, and then 12. Okay? So then again, my leading coefficient is 1, so if I divide all of those by 1, I'll get the same thing, so then these are my possible roots. And then I'm going to do my setup here. And I'm going to put the coefficients of each term. So I have x to the 4th, and then my x cubed, and then my x squared, my x, and then my constant. So again, I've pre-done these already. So I know that 1 will not work. I won't get a remainder of 0. So I'm going to just start with -1. So -1 times 1, and then add these together. And then -1 times -4, and then add those together, and then -1 times 3, and then add those together, and then -1 times -12, and then add those together. Okay. So again, I've pre-done it, so I also know then the next factor that works, so 2 won't, 3 won't, positive or negative. But I do know that +4 works. So now I'm going to go ahead and do +4. So 4 times 1, and then add those. 4 times 0, and then add. 4 times 3, and then add. So now I have a trinomial, and so now I can go ahead and do my normal factoring. So y equals, so my first 0 that worked was -1. So its factor would be x plus 1. My next root that worked was 4, and so its factor would be x minus 4. And then for my trinomial, so constant x to the first x squared, so 1x squared plus 0x, which I don't need to write, and then plus 3. And so this won't factor any further, so then I'm going to stop there. I still want to find my x-intercepts though, and my multiplicity and my y-intercept, but I don't need to graph it because I don't have a final factor. Okay? And that's it for that.